Okay, so in today's notes, we are talking about transformations of linear and absolute value functions, more specifically absolute value functions, since linear functions tend to be a little more difficult to tell what kind of transformations are going on. Horizontal translations are represented by shifting the x value. This is commonly shown in the parentheses and it's opposite the sign. So if I want to move right, it's going to be x minus some number to the right. If I want to move left, it's going to be x plus and then whatever the number is on the left side. Vertical transformations happen on the outside of the parentheses. So if I'm doing a transformation with left or right, it goes inside parentheses with the x. If it's not a horizontal transformation, then it goes outside and not in parentheses with the x, or whatever kind of brackets I'm using. So if I take a look at number 1, it gives me the function f of x equals 2 absolute value of x plus 1. It wants me, without graphing, to describe the transformations from the parent function. So as you saw from 1.1, the number outside the variable, in this case x, is my vertical stretch or shrink. So this one is going to have a vertical stretch of 2. And the reason I know it's a stretch instead of a shrink is because it's a number greater than 1. If it was a number less than 1 but between 0, it would be a shrink. Also, there's this 1 at the end, so it's going to shift up 1. Then we also have reflections. When we have a negative outside of our x, it means it reflects across the x-axis. So over here, this black line is being reflected into the red line. If it's inside the parentheses with the x, it reflects across the y-axis. So over here, it's reflecting across the y-axis. Number 2 wants me to write a function whose graph is a reflection in the x-axis of f. So this is the one where I had the negative multiplied out front. So I'm going to do negative f of x, which means I'm going to multiply everything that was given to me by a negative. So I just rewrote everything inside parentheses. I'm going to distribute in. So distributing the negative to the absolute value, I cannot go inside the absolute value. I want to think of those absolute value signs as like prison bars. You can't get in, you can't get out. So it's going to be negative the absolute value of x plus 3. And then I'm going to keep distributing. I have negative times positive 1, so this is going to turn it into a negative 1. It wanted me to name the function g, so I'm going to call this g of x. B wants me to write a function h whose graph is a reflection in the y-axis of the graph of f. F was what we started with at the very top, so I just ignore my answer for A for now. And this one I am plugging in, instead of a regular x, everywhere it appears, I'm going to replace it with a negative x. So this time, to help us see what I'm doing, I'm going to write this in red. I have negative x plus 3, and then everything else stayed the same. Since there's nothing to distribute here, this is my new function, so I just need to rewrite it. It's going to be h of x equals the absolute value of negative x plus 3 plus 1. Then there are stretches and shrinks. It's a stretch if it's a number larger than 1, and it's a shrink if it's between 0 and 1. So number 3 wants me to write a function g whose graph is a vertical shrink of f by a factor of 1/3. The way vertical shrinks and vertical stretches work is the same. I take it and multiply it by the entire function. So what I'm doing here is I'm going to do 1/3 f of x. That means I'm going to take 1/3 and multiply it by the entire right side of the equation. Okay. So this new function is going to be called g of x. And then I just need to distribute on the right side. I have 1/3 times the absolute value. Like I said before, they're like prison bars. It can't go in, can't go out. And then I'm going to do 1/3 times negative 5, which gives me negative 5/3. Same thing with b. I'm going to do 2 times f of x to get my new thing. I'm going to take 2 times the right side. This one is being called h. So then I distribute 2 absolute value x minus 3 minus not 5. Don't make the same mistake I did. Remember, you have to distribute the 2 to the absolute value and the negative 5. So instead, it's actually going to turn into negative 10. So what I want you guys to do is pause the video, take a few minutes to work on the practice problems at the bottom, and then when you're ready, hit play, and I'll work through those with you guys. Alright, so number 4 wants us to describe without graphing what kind of transformations from the parent function are happening. It has a vertical stretch of 4. And then it is shifting down 9 units. Okay. Number 5 wants me to write a function whose graph is a reflection in the x-axis of the graph of f. Remember, that's the one where I multiply by the negative on the outside. So I have negative, and then I'm going to times by everything that was on the right side. I did not mean to close my parentheses right there. So what I'm going to do is I'm going to go ahead and I'm going to distribute. The negative times the absolute value cannot go in. It stays out. So I have negative absolute value x minus 5. Negative times negative 4, however, will turn this positive. And this one is going to be called g of x. Okay. B wants me to write a function h whose graph is a reflection in the y-axis. Remember, this is the one where I take and plug in negative x for all of my x values that appear. So this one is called h of x. Instead of x, I plug in negative x. And since there's nothing to simplify, I'm just going to leave this like that. Number 6 wants me to write a function who has a vertical stretch by a factor of 5. So I'm going to take 5 and multiply it by the whole equation. So I have 5 times absolute value x minus 1, absolute value plus 2. I'm going to rewrite the g of x part. 5 times the absolute value stays outside. 5 absolute value x minus 1. Then I have 5 times 2, which gives me 10. For 6b, it wants me to write a function h whose graph is a vertical shrink of the graph of f by a factor of 0.25. So this time I am multiplying by 0.25. Okay. When I do it times the absolute value, it just stays outside. When I do 0.25 times 2, I can use my calculator. If you don't have a graphing calculator at home, that's fine for this problem. I just need to do simple math, so I can use my phone calculator. I'm going to do 0.25 times 2, which gives me 0.5.